Dear all, this is the final step of our artificial intelligence class project. And the name of our project is the Close Artificial Intelligence. And I will tell a little bit about the background of our project. Next slide. So moving on to the last autumn season, we found out that a lot of people have faced the problem of choosing the clothes for the next season. And when I went to the mall to buy a new winter coat, I found that I have spent 1.5, 2 hours on thinking, will this coat fit with my trousers, with my sneakers, or will I like it on the next season also? So I spent roughly 1.5, 2 hours, as I mentioned before. And later on, when we discussed it with our teammates, we found that the process of choosing a new clothes is a really kind of a tough one, and people spend a lot of time on this. And after some queries and researches, we found out that the common women spend 4 months for entire life to choose what to wear for the office clothes. And how nowadays people are willing to pay a lot of money to save 1 or 2 hours of their time. And so we find out the benefits of the product of helping people to choose what to wear. So moving on to the next slide.
So our idea is consists of five terms. The first one, we predict the list of the most appropriate collection of clothes that customer is going to like and wear based on the particular part or wall wardrobe. In the second one, convolutional neural network label all clothes with its type, color, gender, and etc. The third one, we determine how likely users are going to be satisfied with the quality and the look of matched kit. The third one, we consider common characteristics and patterns, discover clothes, fabric, material, and group by common traits. Also, we discover users' preferences and group by character traits. Finally, we recommend all possible combination for the given input. The whole system will help users to find the best possible look for particular clothes. Overall, the designed architecture reduces the decision time, creates new insights from daily clothes matching routine. The next one. So our first step is data acquisition and processing tasks. It consists of 4 steps. The first one, we need to be collect data types like images of clothes and feedbacks from texts. Second one, we collect the data from the web crawling online shops or social media like Instagram, user inputs, for example, from the telephone camera, etc. In third one, all data will be stored in data lake. The main reason is that data lake able to deal with unstructured, complex structured data. Moreover, it replaces ETL operations that require high performance CPUs and large disks with cheap Hadoop use. In the final step, we flattering image dimensions from close pictures from 3D to 1D. The next slide.
So nowadays, the computing power and technologies allows us to make our idea come true. And we're speaking about the cloth recognition, classification, segmentation, and recommendation, which are based on the obtained photos or pictures. So it was found out that our project needs to use 3 models: CNN, classification, and DL model. So let's start from the first one. The benefit of using CNNs is their ability to develop an internal representation of a 2-dimensional image, and this allows the model to learn position and scale invariant structures in the data, which is important when working with images. And the main advantage of CNN compared to predecessors is that it automatically detects the important features without any human supervision. And moreover, it uses sliding window method, which optimizes the speed of the whole training process. So our dataset that we used for training the CNN comprises specific single elements of the wardrobe. Moreover, a dataset includes human-picked combinations of the garment. CNN is used for labeling cloth images with its gender, type, and color. For every 3 different labels, we use 3 CNN models. And the accuracy was about 0.83 for gender, 0.8 for type, and 0.79 for color. For the first task, that was gender identification, we used 2 hidden layers. And the activation function that was used in the hidden part of our model is rectified linear activation function, or ReLU. And sigmoid for output layer would label 1 for men and 0 for women. And for the second and third tasks, type and color identification, we use identical topology of neural networks. It has 4 hidden layers with the ReLU activation function and soft marks for the output.
So next was a classification. Classification will be used for classifying certain garment by feedback that users left. Firstly, model was taught to classify comments by positive or negative. Then the average of positive or negative is calculated, and when the result is more than 0.5, that means that most users are satisfied with this clause, and our model can recommend it. The review of purchased item is used for determining person satisfaction. To start with, the spicy model was applied to convert the review text into numeric vector. Then this numeric vector is selected as a feature for model training. The biggest advantage of spicy model is that it takes into consideration the order of words. Moreover, the given dataset has the 5-point rating that we used as a label for logistic regression. To make target binary, we introduced new target for, with 1 if rating was 4 or 5, and 0 otherwise. Finally, the accuracy of trained model reached 0.78%. Oops. Finally, structured data that we received from 3 previous CNNs was used as an input for the DL model. Furthermore, the metadata of user satisfaction was also used that was taken from the classification output in the previous model. Therefore, current DL, the deep learning model that was based on the input data, is capable of finding insights which determine relationship in a combination of clauses. And also we applied transfer learning. One of the most powerful ideas in deep learning is that sometimes you can take knowledge of the neural network has learned from one task and apply that knowledge to separate tasks. This is the transfer learning. Because of the above, we decided to use transfer learning to increase the speed of convergence of our CNN's model.
So now let's talk about the open source softwares that are available for implementation of our project. So Gartner recommends using cloud technologies for the components of design architecture because cloud solution offers the flexibility to scale advanced componential power. Furthermore, for working with big data, we need to use Hadoop. Also, our dataset that we are using mostly consists of closing images in PNG or JPG formats. We assume that the data collection process will be done by web crawling, so we can use free libraries like Beautiful Soup that can crawl websites with JavaScript, or Scrappy, the fastest crawler on Python. Also, we can use IoT or user inputs, how it was said before. A minimum data pre-processing we need to make is image reshaping, so standardized input dimension, and fluttering, convert 3-dimension color channel into 1-dimension vector for deep and convolutional neural networks, since its input layer is fixed. Also, we could apply some image filtering, binary thresholding, and etc. After image recognition, information about this photo is transferred to the classified information that consists of gender, type, and color. ID is the name of the picture. So next.
Sorry, can you turn on your?
Yeah, sorry. To sum up, our final IICT architecture will be end-to-end deep neural network meaning that we are challenged to find appropriate data set with labeled cloth images, as well as pattern matching and recommendation. And consequently, we're planning to use transfer learning mechanism for weight initialization to increase time of convergence and overall accuracy of our final model. And in the future, we're planning to create, as I mentioned, an end-to-end model that will substitute the individual processes that are projected currently. And in the end, we want to have a sole model that can process all the recommendations individually. And the cons of end-to-end are the following. So there will be no explicit programming. We'll be less designing components. And in end-to-end model, everything will depend on architecture and data. That's our main goal. Thank you very much.
So now let's talk about app demonstration. How you can see as the input for our module, it is the ID of image of the clothes. And our model gives us 1, 2, 3, 4 outputs. So this is a recommendation for our clothes by ID 10.0.20. So the input was these trousers, and our model recommends us choose between these both sneakers. Also, it recommends us choose this t-shirt and this cap.